Hello, everyone. Good morning, wherever you are. Welcome to yet another exciting Ask Me session. This is related to the DevOps tracks. So, related to your Stage D labs. So, questions you might be having. Thank you for joining us today. My name is Adjulo Christian. I'm the Assistant Program Coordinator at Hamoye. And joining us today is Peter, who will be taking us on today's sessions, answer your questions that you have. Peter is the CIO of Pyro Labs, a company which helps clients to migrate to fully cloud native business analytics solutions. In his free time, he enjoys orienteering and learning about new technologies such as AI. So, Peter, I'm very happy to have you today with us, sharing your knowledge to interns and explaining to them the issues they might be having. Thank you very much. Um, Over to you, Mr. Peter. Can we start?
Thank you very much. And it's nice to um, be hosted here. And, I like and I have to appreciate the work that you guys are doing at Amoye. And, I feel, it's my duty to be able to help where help is required. And just as he already mentioned, this is we've put this together so that we can help and answer questions that may arise or have already arisen as part of the lab sessions. So my plan today, to be honest, is to start with is have a very free flow approach to things. But if no one has any specific questions, then I will focus on the two questions or two specific areas that I think there's been some activity, or I won't say noise, some general interest in. So I don't know if you have any other questions or anything you'd like to ask, please prepare them up front, because I'd like to have an interactive session, if possible, by Q&A or something. But before that, while you're putting your questions together, I want to just talk about the labs. So so far, the labs that we've put together for the DevOps track, and I hope a lot of you have enjoyed it. I've been seeing some of the submissions so far and going through it. They look very interesting. I know the first labs for the introductory session to DevOps were quite straightforward, in the sense that the idea here was to slowly introduce you to start using things like GitHub for those who don't already know how to use GitHub, and also to start getting us to start understanding the concept of commits, branching, PRs, how to manage code in a team or individually. And then as the labs went on, there was a CI/CD labs, which was the concept here, or the idea was to introduce you to continuous integration and continuous deployment. How is it that when we make a commit into the labs, the repository that we created in the first labs, now how is it that we can commit to these repositories and then have an automated build pipeline, kick off and do things as part of this CI/CD process. So that was the overview of the first of the introductory session and the CI/CD labs. And then the stage D labs, which is more, okay, you've learned how to do all these things, because, just to iterate, the using repositories and using continuous integration is like foundation of DevOps. You can't really say you're a DevOps engineer, or you're a DevOps developer, or even a DevOps admin without having these basic concepts under your belt. And now we start specializing in stage D, because stage D was saying, okay, let's start looking at infrastructure, and let's use DevOps to start deploying infrastructure. And so let me share my screen here. So we said, let's use DevOps to start talking about infrastructure. And so we introduced you to the concept of Docker. the concept of containers. And then we also introduced the concept of Terraform, I believe. So that is what the whole thing was about. And I hope this chronology has, this background I'm giving has been very helpful. I just share my screen. So, now stage D, we're talking about containers and infrastructure, because as a DevOps engineer, obviously you need to know all this stuff, but you need to be able to use these tools, right? So with respect to stage D, we started talking about, let's move over to Docker here. We've got these labs together. And again, the idea with this laboratory session was like, Docker is containers and Kubernetes and all these things. These are very advanced topics. But in order to introduce you to the whole concept, we use these beginners labs where you can, play around with a container that that is hosted for you. So in this case, you don't have to worry about installing Docker, configuring Docker. We're just saying, here's a Docker installation. Go and run these commands on it so that you can have an understanding of what the different commands, the most important Docker commands do. And that's what this is about. Some very nice diagrams here that shows you what happens when you run apt-get and you run Docker container run. And that was the whole idea around the labs in stage D, the first 3 labs in stage D. I think it was the Docker labs. So now, after you've done Docker, my understanding is that there were no issues with these labs. The only thing that might have been the cause of concern is how do you prove that you have completed this lab? When we created this, like I mentioned, just to give you an introduction, there wasn't any really proof or anything required, but it would have been nice. We wanted evidence that you at least ran the last command. And some of you might have just, scroll down to all the pages and just run the last command. And that will get you to where you want to go to. You take a picture and you put it in your Git repository and you upload it. That's fine. But at the same time, you'd have lost out a lot. And I hope, my assumption is that a lot of people probably didn't do this. But if you did that, you'd have lost out on the understanding that this you would have gained by just running through these commands. And finally, once you've done the 3 Docker labs, we introduce you to an advanced topic, which is Kubernetes. How do you now, because Docker just allows you to run a container on a virtual machine. You need to have the Docker installer on the machine, and then you push your containers there. But that's not really what we use in a production environment, in a large scale environment. We need some things that are more scalable. And that's where Kubernetes comes in, Docker Swarm comes in, and then things like Terraform, they start rearing their heads. And so we introduce you to the concept of Kubernetes as an advanced topic. So I just open that here. And I don't know, and I'm looking through the submission so far. I don't believe I've seen any of this yet. Maybe it's because this is an advanced topic and might have not been offered entirely, but it's there. And I'll just talk a bit about this today. This guy here, because I think this was one of the things that people may have had challenges with. Having said that, like I mentioned, please, if you have any other questions about the whole core laboratory structure in general, let me know. But I want to focus on stage D and the different places and stages that I thought would have been challenging. Okay. Just before I go there, I was just confirm that, okay. So what is the Kubernetes like? If a lot of you don't know, hopefully you'd have, used the material that we provided in the learning track. You'd have got yourself some background on what Kubernetes is and how it works in general. So if you had downloaded this repository, it's a straightforward repository because all you need to do is the material is actually provided in this PDF document. You need to have a GitHub account, first of all. So we say you have to have a GitHub account, and you can go to this Play with Kubernetes site. Again, we're not trying to get you to install Kubernetes here. because to install Kubernetes, you are going to be in a position where you need to have the hardware to run Kubernetes. So we're using a hosted environment, right? But it's still an advanced topic because you still need to be able to have an understanding of what a pod is and what this is and what that is, right? So the idea behind this lab is, let's move this to the left here. It doesn't like it when you minimize, make it, take it off the screen. So I'm just going to put it this way here. And then I put this one in the background. Okay. So when this lab, when you get this, what you do is you go here, as we already mentioned. If you did not have a Kubernetes, GitHub account, you'll be asked to log into the GitHub account here, but I already logged in, so I don't need to do that. And then you just open up this PDF document here. And you literally run through the commands in the PDF documents. And you are supposed to have, if you complete this, you end up with a, you get a better understanding of how to use Kubernetes. You'd have deployed a Docker container, and that was hosted on the Kubernetes environment, right? So that was the idea behind this course. Now, I was good. My plan was just go through this with you guys, but I'm not really sure how much value that would offer you guys. But I'll just spin off an instance at least so that you would see, what it's like. Okay. So remember, this is a hosted environment. So what we're seeing here is I just created a node, one node in the cluster. You see, this is a node that has about 4 gigs of RAM, and CPU is not that much, but it's enough to run Kubernetes. Kubernetes can be quite tasking to run locally on your laptops and on your computers, but it's possible using something like Minikube. And so that's the next level. So now if people have done these labs and you've graduated to the next level and you come on board, or things happen, you start using things like Minikube and AKS and EKS. It's one of the labs that we have in the next track or in the next session, which is, I think, this the cloud fundamentals. You'll be able to spin up an AKS cluster in Azure. You'll be able to deploy it and manage it yourself using Terraform. But this here is hosted. You're not deploying anything. You're just clicking a button to have it created. So we created a node here. And Kubernetes is already installed here, but it's not really running yet. It's just a node, right? So to get these things working, we'd have to add an address to it. So I'll just type it actually. I'll just copy it from here. Let's just type it. Kubeadm. So this command here is specifying the IP range that we want to use for this cluster. But to be honest, you don't really have to specify it. The IP range you want to use just for the pods. But I'm going to just tell Kubernetes to provide one automatically. So either one works, to be honest. Okay, so let's make sure this is good. So it's pulling the so it's an amazing world we live in, because this is Kubernetes. but the Kubernetes environment that we're actually going to use for this lab is actually is running in a Docker, in a Docker pod. But we're able to host Kubernetes within Docker just because it's possible, or in a container. So what we're doing here is we're pulling, we passed that here, but we're pulling the containers, we're enabling the different configuration required to run Kubernetes. Like I mentioned, this is fully automated. And you probably don't have to worry yourself about this, but it's a good idea to always know these commands, right? Like kubeadmin and what they're doing. And if you look in the docs, we actually say what we're doing here, right? So you see something like this, and this means you're almost ready to go. You know, you've initialize your cluster networking in the first terminal. So it's just networking we've configured there now. And after that, we now need to get the Kubernetes environment working. So we're going to deploy it to a namespace called kube-system. That's usually the default. Even though you don't specify one, you get something like that defined in there. So we're going to just run this again. Run the next command. Okay, let's just make this directory. Let's check if this exists first. Okay, it doesn't. So let's do some. Let's make this guy here. Let's type it. Okay, sorry, I made the wrong one. And then we're going to now copy our Kubernetes commands, the admin configuration, into our local one. Okay, it looks like it's already there. Okay. I think we should be good. So now we're going to, let's just make sure that all these guys are here. And this has the correct permissions. Okay, that's fine. So let's go back to the lab. We can run kubectl. Let's see if there are any nodes running. So yeah. Okay, so we only have one node, and that's what we use for the control plane. So we're going to add and just keep going with the labs, and we're going to build the Kubernetes system. So the -n here means it refers to the namespace. So effectively what we're doing here is saying, apply this a manifest file, which we're going to download from the internet here, and deploy it to this namespace here. Normally you'll be able to copy and paste this command, but I'm using Google Chrome, and the hotkey for copy, remote copy, also opens up the developer edition. So I have to just type it in. So all this here, just saying, look, we just want to get a version of Kubernetes to install that matches the version of kubectl. And that's why we have to run this command here. Okay, let's just make sure we've not made any mistakes here. Okay, so it's downloaded the manifest file correctly, and it has also applied the manifest file. So now we've created all our security, our backs, and we've also deployed an application called WeaveNet. In fact, if we want, we can actually grab this command here. And if you put that in a browser with the right version, you can view the manifest file that was deployed to this Kubernetes cluster. So if you get kubectl get nodes again, but this time, let's get pods. Okay. Let's check in the okay, so if you check the kube system namespace, which is where we just deployed to, you'll find that we've deployed all these pods are all running in the Kubernetes. We actually deployed this guy here. These ones have been created. This is part of the Kubernetes environment, which when we deployed Kubernetes earlier at the start, they were deployed, but we just deployed this pod here called WeaveNet by applying this manifest file here. So it's the application I actually deployed. This WeaveNet application is it's a Docker coin miner. Obviously, it mines coins, but you can't really do anything with it because it's Docker coins. It's not a real coin. And we've deployed 2 pods here. One of them is a worker pod, and one of them is the parent pod, or I don't use the word master, but it's what directs the worker pod to mine coins. And that's really, in a nutshell, like we can keep going down any further, but I hope this gives like an introduction to where we are. I want to pause, just ask for any questions at this point, because I want it to be an interactive session, as interactive as possible. I know many of you might be watching on the YouTube or wherever it may be, but if there are any questions or anything, then is there anything we can facilitate here?
Okay. Is there any question from any participants? I'll still check on YouTube also. I think there's no question for now. I think they're already following along. Let's see.
Okay, no problem. Okay, so we can continue actually, just to get to the bottom of this. Then, so we have deployed our Kubernetes environment. Now we're just going to continue and deploy the remaining infrastructure we need. And I think it would be nice to see the GUI of what we deploy. So we're going to now clone the application called Docker sample from the Docker samples called Docker Coins. We haven't actually installed it, to be honest. Now we're just going to do that now. But before we do that, we just clone it into our environment here. So if you remember from the first lab, Git is what we use to interact with our repositories. GitHub, the GitHub environment. You can use Git. Git is an application in itself that can interact with any Git GitHub or Git type environment. It's not just GitHub. There's GitHub. There's Azure DevOps. There are other type of repositories out there. But as long as they are Git based, you can use Git to interact with them. So in this case, we're going to interact with this repository hosted on GitHub here. Just going to clone the repository. Okay, so to prove that we've cloned it by ls here, there should be a new folder called Docker Coins. So we've cloned it from GitHub, and now we're going to just, let's see what's in there. Okay, nice, all these files and nice things in there. Okay, so we're going to use Docker Compose up now to start to run this. Now, I would like to believe that Docker is installed on this guy here. Yes, it is. Okay, so what is this doing? In that sample repository here, when you look into it and download it, there are some files. Let me go in there actually. So this is a free repository hosted by Docker, and it's an application that I talked about earlier that allows you to mine Docker coins. It's a sample app just to show you how things work. When you download it, these are the folders you see there. So Docker Compose is it's a tool that was made by Docker, and what it allows you to do is that it allows you to run multiple manifests and multiple deployments as one file. So normally what we would have had to have done in the past is that we would have had to build these different services and deploy them separately. But because of Docker Compose, you are able to just put everything in one file in your Compose and just deploy everything at the same time. And that's literally what Docker Compose is in a nutshell. Just deploy everything one time from one file. In the past, you'd have multiple files for the different services, but now it's just one file. So I noticed this guy has failed here because, oh, this is the disk issue I think many of you might have run into. Okay. If this is the case, then obviously we can't run it in here. So I'm going to switch for the purpose of these labs to the Docker desktop. So Docker desktop is ideally what you should be using, but because of constraints, because people have different hardware requirements and different systems, the idea here is that we wanted to use something that was unique and the same for everybody, so that people won't say, oh, I don't have my Docker, I don't have enough resources to run it. But because it's failed here, clearly there's not enough disk space for me to use this thing here. So I'm going to run it in my environment here. So how do you use the Docker desktop, or how do you even get it? First thing to do is you need to head over to the Docker site. And you can just search for Docker desktop. They have a preference for people with Mac, so you get the Mac versions first. But if you're on Windows or Linux, you can click on that one and you can download it. It's a huge download. It's about 500 megabytes. So I already downloaded it. Anyway, once you install it, you end up, I'm running on Windows, you end up with a Docker desktop environment. By default, it's free if you're using it for your own purposes or for educational purposes. So you can choose the free version and that should be fine. And when you install it, it's going to ask you to configure a few things here and there, but it's straightforward. Just click, point and click. You don't have to do anything on Windows. On Linux, it's the same thing too. You can use apt-get to download it if you don't want to go through the site. On Mac, you can just click on the link. So let's go back to the labs. So clearly that has not worked for us, which is a shame, but we would now turn to running this locally. So I would fire up a terminal here. Okay, so let's clear that and let's make a new directory. So now I'm going to run git clone locally here on my computer. I'm going to go and download the file from Docker. Okay, let's go here. It was, I can just get it from here. Okay, so now, of course, we're not in that Kubernetes hosted session. So you can go directly to the Docker page and clone the repository. To clone it, you can just click code and click copy there. And you can come back to your terminal and you can paste it, right? Cool. So we've cloned it and we're just going to seed into Docker coins. Okay, so I'm going to run the same command going back to the lab that the lab was instructing us to run here. That's the wrong window. Yeah, this guy here. So we're going to run seed into Docker coins. I'm going to run Docker compose up again, right? So what is this doing? This is now pulling the image that we're going to use for our application from the Docker repository. In fact, what I will do is let us jump into this file again so I can give you guys a better understanding. So when we're building an image in Docker or when we're deploying an image, you need to start from a base repository. If you remember from the first labs that we did, that's what you need to have, a base image. And a base image is what we're using here. Why it's downloading all these images and all that stuff, because it's trying to download the base image for us, build it, and run our application. Let's go into this guy. So we're looking for a file called Docker file. Yeah, okay, this one here. So a Docker file tells Docker what to do with, what to do with respect to the application. So here we're pulling this image called Python tree Alpine. It's based on this is the tag, to be honest. This is the repository. This is the base image. This is the tag. And we're pulling that image and we're adding Redis cache. We're adding all the Redis cache package. We're adding the request package. And then we're just going to copy everything, a script called worker.py to the working directory. And then when this container starts up, it's going to run Python and it's going to execute that Python file. That is literally all what this container will do, right? So that's the worker image. Let's look at the web UI image. So the web UI image, that is built using Node.js and it's using a slimmed down version. That's the tag there. And then this guy, before Docker deploys the image that we want, it's going to copy from the repository. It's just changing the working directory to /app, and then it's running an npm install and installing Express. It's also installing Redis. It's copying files to our working directory, and it's copying webui.js. And then when this container starts up, it's going to be listening on what we call port 80, and it's going to be running Node.js, and it's going to be running this UI. That's what this means. So we have multiple containers in here that we need to run. Let's just go back there. That's the web UI. And then finally, let's look at this guy, the hasher. This is running Ruby. So we're copying from the Ruby image and we're using the Alpine tag. And it's installing curl and base build and all those things. It's also installing gem, sorry, Sinatra and thing. And then it's also, when this container starts up, it's going to listen on port 80, and it's going to run in Ruby, and it's going to run in this file. So what am I showing you all this? Like, if you're into mining coins and all this stuff, this is what we're doing here. Is we're just simulating, running a simulation on how to mine coins. That's why you have multiple images here. You have something that does the hashing of the coin, signing of the coins. You have a UI so we can see the coins, and we have a worker that just runs and mines coins. That's what this application is saying here. I'm not a crypto expert, but those are the basics, right? You mine a coin, you sign it, and you put it in your wallet, whatever it is, right? And that's what this application. So we're just deploying the application. It's taken a while to deploy here because, well, as you can see, it's actually running already. It's been deployed already. So as you can see, it's deployed. And these are just log messages that are being sent by the pods to standard out. So it's just logging, it's running, it's telling me it's doing, HTTP calls are being called and being run. So let's try and log into this thing now and see what's going on. So let me fire up another command prompt. Okay. So it's listening on port 80. So let's try going to port 80 on our local desktop and see. Okay, nothing there. That'll work. Let's go into Docker. So another thing that is nice about the Docker desktop is that anything you run from the command line, your containers and all that, you can also, it registers and you can track it from the Docker desktop. So if you don't like UIs, command lines, which you need to eventually you can just use the UI. So while I have all that running there, I can show you everything that's running in that for the application. So for this application, we are running. We're running multiple containers here. This container is called the hasher. It's built using this image and this tag. That's what this is saying here, but we have 4 of them. Now we want to go to the web UI. So let us go into this guy and look for the entry point to the UI so that we can view what's going on in there. I want to copy him. Yeah, open in browser. Okay, so we downloaded the application. We are mining coins. Let's see what's going on here. Let's close this here. Is it running? It says it's running here, but I'm not getting any logs to the UI. Not a problem. Let's see. Okay. So we don't see anything in the UI, which I'm sure there's a bug in there. But if you go and look at the standard out for each of the containers, you can see like any login information is here. So this Python writing out the stuff it's doing. This is the worker. So the worker is telling us what it's mining. It's mining coins here. So because it's not really random, like it's just mining stuff. It's always going to mine 4 units of whatever it's doing. But you can see clearly it's running. The Redis cache is, so Redis, if you don't know what that is, Redis is a fast in-memory cache. So we tend to use it when we want to temporarily store information that can be retrieved, or data that can be retrieved quickly. We don't really want to persist it. We can if we want to, but if we need it to be really lightning quick, faster than a database request, a storage request, we put it in Redis cache. And then you can sort of just use it. It's an in-memory store. So instead of storing things to disk, it stores all your data in memory, which is faster. And that is this lab in a nutshell, really. And the only difference between what I'm doing here and what the lab is doing is that the lab is running on a hosted environment, which I've now made aware that I think this is the storage error that many of you would have hit, but that's the difference. This labs here is running in a Kubernetes cluster, while my local labs here, I'm just running it in a Docker, in some Docker containers here, nothing on Kubernetes. So that is it. I think that is it for the labs. Are there any questions or any feedback about this? Anything
Okay.
I've done here? Yeah.
Thank you very much, Peter. That was very interesting. There are some questions on YouTube. I'll just read them back for you. Okay. The first question from Owolabi. He's saying, what are we to submit for the stage D labs? Is it just a screenshot of the page showing the last command, or all in one repository?
Sorry, or what was the last statement, or what?
Is it all in one repository? Are they supposed to submit just a screenshot of the page showing the last command, all in one repository?
Yes, all in one repository. You don't have to create multiple repositories. Just create one repository, and you can create folders if you want for each one of the labs, and then just put the picture in there. Yeah.
Okay, thank you very much. Then there's another one from the same Olabi saying, what to do when the first 4 labs show me a storage error when pulling the images?
So I believe it's going to be this error here you might be talking about. If it's this error here, okay, this is now an error that we have just encountered for the first time. Because I think what may have happened is that when we first created this environment, they had a different instance of their labs, and they had more space allocated to the pods, and they might have reduced the size between when we deployed the labs and now, unfortunately. So that is the reason why we run it in the storage space. So it's no issues on your end, but now that you've run into this error, if you want to take this further, what I will suggest is, and I can put this down into a quick document for you guys, just install Docker on your computers, and then just do what I did. Just go and clone this Docker coins repository, and then run it locally. Yep.
Okay, thank you very much. So I'm guessing Wallaby, your questions have been answered. So that's for that. Then there's another question from David. Okay, I think you answered before. Saying, what should be submitted in the last lab that's for infrastructure as a code, lab 1 exercise?
Okay, let me see if it's lab 1 exercise. I think just going back here, it was the Docker ones, right? So let me just. So it was introductory to GitHub and CI/CD. So those are so for the first couple of labs, this introduction to GitHub, the idea here was to get you guys to build and learn how to use GitHub properly, and eventually be able to use actions. So for this lab came in, you had 4 different steps for this one here. And you were supposed to be able to use this and complete. You just need to submit the link to your cloned repository. The ask was that you get this and you clone it. You create your own clone. I think it was to clone it or to fork it. Anyway, just send a link to your own version of this, and I think you'll be good. Because if you follow the steps, let me just make sure it's clear here. Yes, you're supposed to just fork this, to be honest. What does that mean? It means you go here and you create your own copy of this code That's what this does. And a lot of you already did that because I saw what you did there already. And once you do that, then you can start yourself walking through the steps here, how to create a branch. There's some guides here, some videos and all those things. But if you completed this, you end up in a situation where you submit your branch. You will see all these actions here. These actions will all have the last run for each one of these actions will be green. And that means you have completed the lab. Because if you submit it, if you just clone this and don't know, basically not working on this lab means that you have empty stuff like this. Yeah. So it's okay to submit a lab where you have failures because obviously if you can't get to the end, but at least you tried. And that's what we're trying to do here. So for the labs, these actions, if you follow the instructions on the first page, you'd have completed those actions that I showed you there. That's for this one. For the second one, the continuous integration is the same thing too. Because when you create your own copy of the branch and you go through these steps, at the end of the day, you end up with actions here. Let's copy this here. You end up with actions here that would have been completed. If the actions are not completed, that's fine. There will be pull requests. So that's how we're going to be examining and scoring these things. Like if you follow the instructions, I expect to see pull requests. I expect to see actions. I expect to see different things happening in the background here. I created a copy of this in my own personal Git repo, and I ran through this. And let me see if I can find it. But effectively, that is what you end up with. Let me just put it to the side. Sorry, are there any other questions while I just pull this, just for the sake of time?
Okay, yes, there is. From Olabi, okay, said he was actually talking about the Docker Labs that it runs into a storage error. I guess you've answered that before.
Yes, I just answered it. Yeah, so this is the storage error here because the pods don't have enough space. When we created these labs, this is a hosted environment. Like it's a free hosted environment, so they can do what they want. And clearly they've gone and reduced the size of the disk available. So now if you try and clone, it doesn't work, unfortunately, just going by this. So what I'm suggesting is download Docker, the Docker desktop environment, and then just continue the labs from where it failed in a Docker hosted environment. When you have installed the applications for the Docker coins, you'd end up with something like this, right? You can either take a screenshot of this and put it in your repository, or you can go to the command line and just run the Docker command, and you can tell us what containers are running. What would be very important thing is that so you run the ls command and you see these are the same containers that are running there. In fact, this is probably the preferred approach because I want you to be able to write your name in here when you run this ls command. So that at least we know that you haven't copied somebody's image. I'm sorry, but it's just, to make sure that people actually do it properly. Exactly. So you can just do something like that. Yeah. And it will print the container and your name will be there. And that's it.
Okay, thank you very much.
I will document this if it will help so that people that were not here might be able to continue with those labs.
Okay, thank you very much. I guess he already has an understanding of, as I has already gotten the answer to this question. Okay, there's another question here on Zoom. This is like a technical question. It's from Jiba. It's saying, I downloaded Docker, but I'm having serious issues with virtualization. How do I go about it?
Okay, this is the reason why we wanted to use that web one, because installing Docker sometimes, most times with Docker, when you have issues with virtualization, is because you've not enabled something called, if you're on Windows, you need to have enabled WSL on Windows. So I should probably get a new settings. and start working. But to enable WSL on Windows, you have to just, you go into settings, right? And then you have to just look for it somewhere here. Extensions. Okay, there you go. So you have to make sure that if you're on Windows, you're using WSL as the base engine. Because if you don't do this, it's going to try and use something called Hyper-V, which is a virtualized, feature of Windows, and it's not really that compatible with Docker. So please just make sure you have WSL to enable. If you don't have it enabled, just click this Learn More here, and it will take you to a page on how to actually download WSL. So WSL is just Windows, SUSE Linux, right? It's just pretty much a subsystem for Linux, rather. And it allows you to run Linux on Windows.
Okay. Thank you very much. There's another question from David. He's asking about what to submit in the last exercise of infrastructure as a code. Because he said since there are a number of what to do from getting started with Terraform.
That's a very good. I think it's one thing we didn't really talk about here, unfortunately. But so with respect to that labs, let's go in here. I think we had it open somewhere here. This one, yep. So with this labs, depending on which tract you go to. So again, this labs just starts out trying to show you how to install Terraform and just some very simple use cases on how the different concepts of Terraform. But the actual lab itself is to make sure you attempt one of these tracks. Hello?
Okay.
Oh, sorry, I thought my my battery had died on my headset there. Sorry.
Okay.
Can you hear me, by the way?
Yeah, I can hear you clearly.
Okay. Yeah, sorry, I didn't finish what I was saying. So you need to attempt one of these. Okay. Yeah, and in terms of what to submit, you need to submit, would be nice if you can submit, so if you go down the Azure path, you can log into Azure and you can submit the list of the resources that you have created. I'll send you a command on how to get all the resources you have created. And then that would show us that you've actually created those resources. It's just a simple command you can run from the command line. You log into Azure and you run the command, and it shows you what resources you have created or deployed using Terraform. So it's the end state for us, really. You can deploy it, ideally you shouldn't really be trying to deploy those resources manually. You need to deploy them using Terraform. And finally, actually, what else do you need to submit? Submit the code that you used to deploy into any of these environments. Just submit the Terraform code. And that will be get us at least 80% of the way. And if you can log into those environments and get a list of the resources you deployed, that'll be perfect. So commit the code into your repository, get a list of the resources, and also just put that in your repository.
Okay. Thank you very much for that. So I'm guessing you already had answers to that. Okay, currently there's no further questions on YouTube and also on Zoom. So I'm guessing this has been very, very enlightening to the interns. So for those that probably are just joining or haven't joined, this session the videos are available on our YouTube channel. You can always go over it again to see if you are having any issues. You can always go over the video again to verify your doubts. Okay, in the absence of no further questions, I guess we can call it a day. There's no other question. Thank you very much, Mr. Peter. Okay, there's a question.
Yeah.
Jiva, do you have a question?
Okay, thank you very much, Mr. Christian. I just wanted to say thank you to him. And then I want to beg that we should please have another Ask Me session for the next stage, because this has really helped to clarify some issues we're having. Thank you.
Okay, no problem. If what
You're welcome. I'm happy you're enjoying these sessions. Thank you.
Thank you very much. If we are to have another session, we'll let you know. So, but I can't assure you for now. So, in case of any other session, we'll just let you know. Okay, thank you very much, Mr. Peter. This has really been exciting and enlightening to intense, and letting everybody enjoy the session to ask clear their doubts or whatever question they have. And if they are still having further questions, you can always come back to this video. It dealt with a lot of issues. For those running into storage errors and not knowing what to submit to the labs, he has already clarified all that. Thank you very much, Mr. Peter. I'm very, very grateful for this session. Thank you very much. And to the interns, you know the deadline for submission of the deliverables. Please do well to meet up with it. There won't be any form of extension whatsoever. Thank you for those joining on the chat and also on YouTube. See you again next time we'll be having this session. And once again, Mr. Peter, thank you very much. You can say thank you enough for clarifying the air. Thank you very much. Okay, this is the end of today's session. Everybody enjoyed it. My name is Christian. See you next time. Have a wonderful weekend. Bye for now.